Welcome to another episode of the .NET Show. This will be our last episode for a while that we cover about Longhorn technologies. So far, we've given you an overview of Longhorn. We've talked about the various pillars of Longhorn, the WinFS, Avalon, Indigo. Here we're going to cover the final pillar of Longhorn. That's one we refer to as fundamentals. Now, fundamentals isn't specifically a technology. It's more of a concept and an inclusion of a number of different technologies that will assist you in writing better applications, more secure applications, more robust applications, and applications that give your users a better user experience. But before we get to that, let's check in with Erica and the news.
Hello and welcome to the MSDN News Update. I'm Erica Wiechers. On May 3rd, Microsoft announced a new localization solution for applications that run on top of its Windows XP and Windows Server 2003 operating systems. This new solution, called Microsoft Application Translator, enables applications to offer on-the-fly localization with no code change and limited investment in localization. Microsoft is now accepting applications to join the MAT beta testing program. During his keynote address at the 13th Annual Windows Hardware Engineering Conference in Seattle, Bill Gates unveiled the future of Windows computing, including an innovative Windows Home Concept PC developed in collaboration with HP. Other new technologies highlighted at WinHEC included Windows XP 64-bit Edition for 64-bit extended systems, the device's profile for web services specification detailing how to connect smart devices via web services and preview developer kits, and an updated version of Windows Longhorn developer preview code for device manufacturers. Microsoft now offers free security e-learning clinics for developers. The clinics follow the same content as the Microsoft Security webcasts, but deliver that information via a learner-centered format that offers unique user benefits. Developers can access what topics they want, when they want it, and learn at their own pace. Check out the new clinics at https://www.microsoftelearning.com/security/developer. Given increasing security issues in the industry, the publishers of MSDN Magazine announced at TechEd the debut of a new magazine aimed at IT professionals. The magazine, which will be called TechNet Magazine, will be the leading source for in-depth technical information for IT pros using Microsoft products and technologies. The first issue, available this fall, will be devoted entirely to security. And this has been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Like I said, today we're going to talk about Longhorn fundamentals. Now, fundamentals really aren't the same sort of topic as Avalon or Indigo or WinFS, but it's a different aspect of developing applications that we think is really important to think about. Help us understand what the fundamentals mean for Longhorn as well as today's application. I have with me Sanjay Shenoy and Glenn Pittaway. Thanks for joining me.
Thanks.
Now, what exactly do you guys do here at Microsoft?
I'm a development manager in the core operating system division, and I worry about things like deployment and how do you describe applications correctly and how do we manage them and maintain them.
And when you say core operating systems, what does that mean?
This is the Windows division and the part of it that's related to the core technologies like the kernel and the component model and so on.
The real geeky stuff.
Yeah, the core of the system, the heart of it.
Yeah, okay. Glenn?
I'm the Group Program Manager for Windows Core Security, which is part of the Security Business Unit. And basically, we provide the security infrastructure in the platform. So from the time that you enter Control-Alt-Del to enter your logon credentials or insert a smart card, to the time that we actually decide that we're going to use Kerberos to authenticate you, basically we own that path.
Mm-hmm. Again, it sounds like a pretty geeky level of the system to deal
Yes.
with. Now, I know that with all the newspaper reports and stuff like that, security is becoming a far more visible issue we're dealing with. But security is nothing new to Windows. We've always had groups working about security and stuff like that. How are some of the things that we've been doing in the past evolving forward to today's operating systems as well as Longhorn?
You have to separate security in the sense of the things that you do to make something secure from the kinds of things that can be exploited to give you a security problem. So in the sense that the security vulnerabilities that make the news, most of them are not particularly security related. It's a common confusion to confuse security with quality. So there's a point there which is more of a process thing. So if you talk about, for example, the trustworthy computing development process, that kind of addresses the quality side of what most people think of as security. Then when you actually start to think about the things that we've been doing in the last probably 8 to 9 months, focusing on Windows XP Service Pack 2, really it's about making sure that the system itself has a high degree of resilience to the kind of things that you often do see reported in the press. Moving forward to Longhorn, then we start to think about how we have the running system isolated from those kinds of problems. It's a fairly arcane subject, but a lot of it really is about protecting people from the wrong things they do, and less from the bad things that they do.
Mm-hmm. So it's more also thinking about the more malicious sort of aspects associated with things rather than normal operating procedures.
It's protecting them from doing the wrong thing in many instances.
Yeah.
So, there are certain classes of things which it's actually technically very hard to stop them doing. So if somebody sends you an attachment in email, solving the classes of problems that are caused by people loading software onto their machines. On one level, there is not really much difference between taking a CD from Microsoft and putting it on a system and downloading something. You're actually installing software on the system.
Mm-hmm.
This plays very much into the kind of things that Sanjay has to think about.
Mm-hmm. So how does it deal with some of your stuff then?
Some of the things that we've been worrying about is, if you take what we mean by fundamentals, first of all, I think if you look at Avalon or Indigo or WinFS, they're about providing better capabilities in the application. But one of the big burdens an application developer has to face is, okay, I'm providing this cool value here. I'm making my app do very fancy graphics. It can talk to other very interesting web services. It can provide value there. But the overhead of just managing the application through its life cycle is a real burden. And we keep hearing about how deployment is an issue or how managing an app once it's out in the corporation or out in a broader sense, if it's an ISV that's deploying a broad-based app, how those are issues. And we want to really take a look at that in Longhorn and see what are the systemic problems here and how do we address them. So we are starting looking at deployment with click once and Whitney as one of the things we are focusing on. And we want to really build on that in Longhorn and provide an experience where, as an ISV, if I go down this route and build a WinFX app, I really have a much better experience on these on these aspects. That's how I would really differentiate fundamentals, and I think security falls in there from the capabilities your application provides.
I think that's an important point in the sense that development is often focused on what you think your customers want and the features that you provide to solve those customer desires. But in fact, the way that we try and look at it is that with the fundamentals, it's your development process, it's the experience of the user from the first installation of the product, it's the management of the product while it's running, and it's deinstalling the product at the end of the day. All of those things seem kind of to get less focus from a lot of developers, but in fact, those are actually a huge part of the customer experience of the products that people develop.
Mm-hmm. Mm-hmm.
Like a common experience, I think, for many application authors used to be, setup is something you do at the last minute, where after all the cool stuff is done, you throw somebody junior at it and say, oh, go ahead and do it. Whereas we want to really bring it up front. Right? We want to say, as part of the process of building your project in Visual Studio, as you're building the project, the fact that whatever you need to do to get it set up and to take it through this life cycle is very much upfront. It's very much required. It's not something you do as an afterthought. And it's as fundamental to the description, say, of the application as we've made metadata be fundamental, say, for people who are familiar with managed code. Putting the type lib later or defining how you interact with the system later was always the option, and you could always do it later, and you got it right sometimes, you got it wrong. Now we're really trying to say it's required, and we will help you through the life cycle, right when you're designing your application to give you guarantees that the right things are happening.
And I guess part that falls into that is that thinking about what you're doing as you're developing the application also includes, from the standpoint of where are the components you're using? What are the system settings you're needing to use in the application? Because it's so easy to be developing your application running as administrator and be able to do anything you want to do. And then at setup time, that means a person has to be running as administrator when they set up as well. And I think that's a really important thing we need to focus on.
Yeah, that's definitely one very important aspect of it. I know most people have experiences where for example, when my daughter wanted to install her first game, I had to figure out, oh, now what do I do? She has to be administrator, or she's not administrator. I have to go in and provide it. We really want to provide an experience where things about running as a normal user on the system. I know Glenn's team is very involved in this. Also, it's just fundamental. It's the way applications are built, so you don't have to ignore it or not think about it initially and then do a lot of work to actually get it right. Just out of the box, applications are designed to work the way we'd like them to. And then there are special tasks like admin tasks, which is a different model, which is a different, smaller section of applications. But for the vast majority, what running as normal user is the right thing. And we want to make it very, very simple for people to do that.
I think a lot of it is actually to do with being a good citizen, because Windows is an ecosystem, really. Once you install Windows, if you only run one application on it, it's not really what Windows is about. And everything that Sanjay was saying, you think about the fundamentals means you kind of try and think about it from a more holistic sense. So you think about the privileges that you require in order to run your application or install your application. And then you think about the kinds of things that you do and how they interact with the system. For example, thinking about, are you going to ever require your user to authenticate? What kind of things do I want to do there and take advantage of system services? And the wider thing, if it's a distributed environment, for example, you're writing an enterprise application, and really trying to take that holistic view. If you deinstall your application, how do you try and think about it from the point of view of you're not going to break things that are already there?
Yeah, I think there is the thing that you need to think about it. And we are also doing some work specifically to say that we want to really encourage patterns in the system that make it easy to get them right. That's also a focus, because there are patterns in the system today sometimes which make it harder for you to get it right. For an example would be registration, right? Me as an application, I come in, I want to interact with some other part of the system. The onus is on me to go put some values into this other part of the system, which other people in turn also are probably trying to influence. And somehow when you have this multi-application system, all of that has to work together, and you have to get it right in terms of, you're all now essentially contributing stuff to a shared space. Right?
Sure, the shared resource, the registration database, is just this big free-for-all location. So how is that advancing moving forward then?
So what we are saying is, instead of the onus being on the application author to go essentially describe parts of their metadata scattered across the system, there is one definitive document, the manifest, which you will see, and you can see some of this in Whitby, which says, I am the application and these are the things, these are the ways, these are my own resources, and these are the ways I interact with the system. And then the task of taking that description and actually saying, how is the system composed, is a system level operation, as opposed to leaving it to individual applications to say, oh, I'm going to go change this registry key, and if there was somebody else before me, I need to figure out what to do about it or not, or get it wrong.
Now,
Is that
to me, that sounds like we're almost going back to the old .ini file. I mean, I thought the registration database was supposed to, solve some problems that any files had,
Correct.
and registration database just kind of brought a whole new set of problems to it. How's this manifest thing different than either one of those two methods?
I think any files had a bunch of issues, but let me describe what a manifesting does. So you describe your own resources, which are close to you, just like your metadata should be, which I think is the easy part. It's when you're interacting with other parts of the system, right? Any file had the same issue where you would go contribute to win.ini, and multiple people would try to go into win.ini. Here we are saying is, you just say, I want to be an XYZ, or I am capable of showing multimedia files, or I am such and such a security provider. You try to keep the description close to the application. It's always there available with the application. When the system sees there are multiple of these, it applies its rules to say, okay, therefore, this is the right thing now to be the default provider if there is a case like that. And also we can always get back to the original state. We always know that this application is a security provider, whereas what happens in today's model often is app A came and changed an area, app B came and changed the same area, and then we just lose the fact that A was also a security provider. So we are trying to say apps are self-described, and we can always get the information about the app's capabilities in the manifest with it. We don't have to depend on multiple people, getting it right.
But think about the manifest as being more than, it's not just about the data. Um, some of the things that we're trying to think about in Longhorn is currently the security model in Windows is really based around the user. Once I've authenticated myself to the system, the processes that I launch have a security token on them, and then authorization decisions really are made based on my user identity. If you can take a leap forward, and Sanjay was kind of touching on that with the metadata aspects of it, of identifying an application in some strong way so that I can really understand what the implications of app A doing something, so that when I roll back app A, app B isn't really impacted. Manifests actually maybe give us a stepping stone to actually having a strong idea of what an application identity is. And we're hoping to actually do some things with that give us the ability to address some of the problems we talked about at the beginning. So, for example, if I do open an attachment in an email, then maybe I can protect my my contacts data in the file system from that application, from that malicious application having access to that, and protect private data on the system. So the manifest, if I think about myself as a user and the current authentication and authorization model, I use my username, I use a password or a smart card to authenticate to the system, and then I authorize, the authorization policy is applied. The manifest gives us a way of identifying the application, and hopefully we can authenticate effectively the application and provide authorization based on the application's identity. So it's actually a very important step.
Now, a lot of the things we've been talking about, with the security, thinking about the setup of the application, understanding even just how to use the registration database properly. If people had used that properly to begin with, we probably wouldn't have some of the problems we have now with it. A lot of that to me sounds like just some common sense sorts of things that application developers could be doing today. Why is it that the concept of the pillars of Longhorn includes this pillar called fundamentals that is standing beside WinFS and Indigo and Avalon?
But define common sense. I mean, from a developer point of view, common sense might be I do the things that make my product work. But when the fundamentals make you think about it in the wider context, so that when the fundamentals make you think, well, the product will work in that particular instance, but maybe you don't want it to work that way. So if you take the line of the way things have been since Win9x days, when really, applications would write data in all sorts of parts of the system, people have often carried that mentality in the way that they've moved their applications on the platform. The fundamentals make you think about it from a more holistic point of view, and you actually start to say, well, common sense actually means that I have to be a good citizen in the operating system as well.
Yeah. And I would say it's actually difficult. It's not common sense, because if your model is you are one application sitting on top of the operating system, and you can pretty much do whatever you want to do. Yeah, there is a set of things you could do which make it easy, right? When you're actually talking about managing multiple applications and interacting with the system, we do need to have a much more prescriptive and much cleaner way of doing these things. So the onus is not as much on the application author. So there are two models, right? An application author might assume the world is very simple. I'm just going to go and write registry keys, or I'm going to go do whatever I need to do. And then when they realize there are interactions with other applications, they hear about problems later. Or there are applications that actually spend a lot of time up front to try to do the right thing. But to be aware of the fact that there might be other people who are playing in the same space. And that is a difficult thing to do. What we want to do is to say, we want to make it easy for people to be in that second bucket. I think some applications get it right, but for most people, they're more interested in getting the applications out, and we need to make it easy for them to do the right things as far as managing some of these interactions. That's really.
So the fundamentals pillar, are we using that simply as a way to draw more attention to that topic, or is it also because we're actually making some severe modifications to the operating system itself to better support that structure?
I think it's a mixture of both, really.
Yeah. I think a lot of the latter as well, because there is actual code changes happening, as I mentioned, the manifest, and we are building services on top of it. Click Once is a good example of something we are starting to build, and we are seeing the first version of that in Whitby, where based on this new application description mechanism, we can actually provide a service on top that makes it really easy to update an application. Because there's less guesswork involved. I mean, it's as simple as that. There is the description of the application before the update. There is a description of the application after the update. The system can take care of giving you the diffs, right? That's just a small step, though, right? We want to take that forward, and we want to look at the life cycle and say, okay, let's take eventing, for example. I don't know how many people spend time looking at NT event logs. I have to do that a lot because I'm, and for a lot of people, it's very difficult. There is lots of, information people don't understand. So, and there is lots of unnecessary, you have to wade through tons of information before you find what is useful. And so we are looking at some of these problems from the basics and saying, what is it that we need to do to make it easy for somebody when their application is deployed in the field to get the right information, for the IT person to get the information, for the developer who's trying to diagnose a problem to get information. So there are a bunch of changes happening in the core operating system to support some of these.
And so, what do you think are some of the most important things the developer could be doing today in their application development that could be also thinking about the fundamentals, preparing them for the programs they're writing for Longhorn?
I think my main message would be to think about your application from the user who's going to use it. And if the user should be somebody who does not require admin privileges, or the tasks that you're doing are not admin style tasks, then actually think about developing your application from that point of view. And it may well be as silly as testing it or developing it without using admin privileges.
Sometimes that can be pretty hard, though.
Yeah, it can be, but at least you can test it that way.
Yeah.
The thing is actually have that frame of mind to start with, because so many problems are caused by that mentality. That, if we could flick the switch and say that the users could run as normal users all of the time, things would be so much better.
Yeah, I would say I would very much agree with Glenn. Testing your application to run as normal user, as a regular user and not an administrator, is a wonderful thing in terms of giving your customers the right experience, but also it helps you weed out a lot of just bad assumptions, I think, sometimes that are made. I think the system since Win2K has really moved in a direction where it's really possible to write these applications. There might be an exception here or there, but for the vast majority of cases, I think it's either lack of information maybe, or people just didn't bother and they said, okay, let me write it as admin because everybody's admin in any case.
I mean, and I can see, if I was writing an admin tool, I would probably need to have someone be admin. But if I was writing a game, like you were saying, you're downloading the game sort of thing, that just makes no sense whatsoever. To require admin level
So
privileges.
that's really about understanding what your customers are, or who your customers are, and what they're trying to do. And if it's a 4-year-old child who's going to install some infotainment kind of title, then you should be ashamed if you're going to require them to be a member of the local administrators group on the machine.
Of course, the person writing, maybe his daughter really is an admin on the system.
May well be. Child prodigy admin,
Yeah.
But that's not usually a very large customer base.
Yeah. The click once, we've talked about that several times. I know in my mind, I feel that is a very important aspect, and there's an awful lot of things tied up in that. One is just purely the user experience of simplifying. And in the past, the MSI file and stuff like that almost made it, so that they intended you to go through several dialog boxes that you had you're just reading a message and clicking OK on it. And it says, yeah, that's the right directory to put it in, click OK, and you're constantly clicking on stuff. But I think another side of that, it has to be tied up with security and thinking about the whole aspect of how do we really simplify bringing an application down off the web, installing it on my local system, so that not only is it a simple click once experience, but it's a secure experience too. And those two things almost seem contradictory to me.
It almost goes against the spirit, because if you think about the nature of the problems that you have to deal with from that, you're basically talking about, I wouldn't say they were untrusted or trusted. The trustworthiness of the application is basically, in many instances, completely unknown. If you figure that that you can't trust the application, which is the safe assumption to make, then how do you actually provide the protection that's needed in that instance? Now, in some instances, I could imagine that I could provide the kind of things that, like, again, go back to the edutainment kinds of things. If I'm going to try and provide you with access to some streaming content or something like that, I can see how that works pretty well. But a fully featured application, the problem always comes down to how you deal with collaboration in that environment. So that is actually an extremely hard problem to solve. If I don't trust an application, then how do I allow it to collaborate with the system? Printing is an example of collaborating with the system. Do I trust the application enough to when it wants to print, to tell it where my printer is or what the device name of my printer is? That actually might be some information that I don't want it to know. If I want it to be able to have access to an Excel spreadsheet, do I really want it to crawl through my hard disk? Do I even want to give it the path to the file? There is a lot of mediation problems that you have to solve to think through that problem. So that is an extremely hard problem to solve, and we're trying to look at that from both the managed and the unmanaged code point of view. You know, so there's a lot of things going on in that area, but it is an extremely big problem.
And I suppose solving some of those problems has to do more with Microsoft actually building infrastructure into the system to provide those protections, those shields against access to information. And the developer is just making sure he just makes this open file call. And rather than having the open file call actually look through the hard drive, it's allowing the user to tell the application, here's the file, and stuff like that. So the application isn't thinking about security. The security is just happening for them automatically because it's security setting of the application. Does that make sense?
In some cases, you're saying that automatically under the covers, because we know that this application needs the user to prompt. The user should know that a file is being opened. That we can under the covers do that. Is that?
Yeah, I mean, like one example early on that people are talking about is let's say you're an application developer and you're writing an application that wants to open a file in the operating system. If security is tightened up, rather than the application simply saying, well, let me hit the hard drive, enumerate down, find the file, and open it up. Instead, the application brings up an open file dialog provided by the system, and the user navigates that dialog box, finds the file, passes it in, and all the operating system does is passes a handle to the file rather than the path of the file to the application.
Right.
That's the kind of mediation services I was talking about. It's hard. It's actually there is another problem now, though, which is actually understanding the intent of the application and what it's going to do. So even if the user does it, what's the scope of the user's consent to give access to that file? And that even if you can mediate the access there, what does the application do with the file afterwards? You know, there are a lot of very hard problems to solve in that area.
And what if you're something like Visual Studio, that it's not just one file you're needing, but it's an entire project set of files? Are you requiring the user to pop into that dialog box for every single file over and over and over again until finally the application has all the files it needs for its job?
That's one of the big challenges of security, really. It's like consent, because people will typically consent to whatever is the easiest thing to get them where they think they want to go. But the implications of their consent and getting over what that is, that's a very hard user experience problem for security to solve.
Yeah. I'm just going to say that there is definitely a class of applications, I think, which you trust, and you have a relationship, and you say, okay, this application, this is my backup utility, it's Visual Studio on my machine. Inherently its job is such that it's going to look at parts of the system for me because that's what I expect it to do, or it's going to look through my project files. And then there are scenarios on the other side which are more about if I'm just doing rendering, where why should it be allowed to run there? So I think we have a model for the applications that really don't need some of these capabilities, that mostly are doing safe things. And then how do you actually incrementally go from there to a model where, and what are the reasonable steps in the middle? Those are some of the challenges, I think. What are the buckets? I also wanted to add that I think when you said click once is about making the experience simpler, I think there is a little more under the covers. It's not simply the fact that the experience is simpler and you were able to click only one dialog. One of the reasons why we can make the experience simpler is because we know that when the application comes in, it is very well contained. So for example, if the application is running with the lowest code access security permissions, we know both that the application's impact itself is contained, that it's not going and touching registry keys either during setup or outside, so it's not going to affect your other applications. We know that we can remove the application because the system is managing the application. We can always remove it correctly. So this allows us to actually provide a user experience where updates can happen in the background and we don't have to keep informing the user. The model is simpler, we can contain it, and that actually allows us to do that better user experience, right? It's not simply that we remove dialogues, it's that we really made the system impact much less, and we also are working on, saying that there are classes of applications where the security impact, which is even after it's running, the impact is pretty contained.
I mean, we're both thinking about the user experience of installation, but also we're thinking about the system impact of installation as well at the same time.
I think it's hard to separate both
Yeah.
because ultimately the user experience, who's the user? Is it the administrator for the enterprise? And his experience is pretty bad of the application if the application is leaves the system in such a state that you have to reinstall. The user, if they lose their data as a result, what's their experience? You have to think about the whole.
So how do you think we're actually trying to address this on Longhorn in a way that's different than we're addressing it today on Windows XP and Whidbey and stuff like that?
So as I said, one of the aspects is system impact. And there we are really trying to get a model where the whole application is self-contained. It comes in, we can always remove it, and we can track exactly what the impact of it is on the system. So, if it's trying to get into one of these global spaces, then we know we can track it, we can revert it back. And then as far as security goes, right, we've been working on code access security in the managed code. But the first steps we're taking is making sure that making apps run on Lua is a reality.
On Lua?
Least privileged user account.
Least privileged user account, which is the regular user account, not an admin account.
So it goes back to the point we were making at the beginning, which is write your applications so that they don't require admin privileges. But there's kind of a number of elements. Some of the work we're doing is to try and make it so that, as Sanjay was saying, since Windows 2000, it's been increasingly possible to write your applications that way. We're trying to close the gaps on that. And then also in terms of the impact management side of things, if all of the applications that people write going forward were Lua, then that's the tip of the iceberg. There's all the applications that already exist. So the impact management side of things is also trying to address how the legacy applications behave in that kind of situation.
Because that's important to consider the legacy applications. I mean, when Longhorn comes out, we don't want it just running Longhorn applications. Compatibility is extremely important. And so if we're adding the security features, having that security features be backwards compatible.
Well, it's not about security features. It is just fundamental OS capabilities. And most applications probably only experience security completely contingently. So, the user is logged on, so the authorization decisions are based on whatever happened when the user logged on. It's not about security features. It's only indirectly that way. It's trying to access a file. It's trying to store some of the user's state, the game high scores. It's trying to do those kinds of things.
Well, it's like collaboration. It's collaborating with the system.
I actually like to frame it that way. The problems are relatively conceptually easy to understand when you think, oh, well, I can isolate the application and give it its own view of the operating system. But very few applications will work in that sense, and the operating system itself has to be collaborated with.
I mean, some of the richness of Windows, the experiences of Windows come from this kind of collaboration, right? The fact that I can go into a shell view and see Office and see the Office icons and see that this is an Office-related thing come from this collaboration, the rich experience to the end user. And so we do want to preserve that, right? We don't want to say applications are just silos that don't, interact with each other completely, but we need to do it in a controlled fashion. There are also a few other things, as you were asking this question about what are we doing in the fundamental space, that I should mention that are really important ones in my mind.
Yeah, we were talking all the time about security stuff like that. Maybe there's other things we need to be thinking about too.
Yeah, so besides deployment, which we also spend time on, things like settings management and configuration is an area which we are looking at. And we are making some initial progress in Whidbey, which is the next version of the .NET frameworks there. And we really also want to say that instead of your app's own settings being in the registry, we want the description of these settings to be based on the same manifest document that I described, the application manifest. And you can describe your settings. You can describe attributes on their settings, like should they be roamed, should they be how they should be migrated, and so on. And then the system will provide all the services to actually allow IT admins to configure those applications, and also to other facilities such as roaming and migration and so on based on that metadata. So we are doing some work there, and we are making it really easy for people writing managed code in Whidbey by actually having a base class that you can just derive from and add your settings there and attribute them appropriately, and the rest of it is handled by the system. That's something big that's going to come in Longhorn as well. And I mentioned eventing briefly, but that's another area where we are doing a lot of work to say, describe your events and the type of events that you're doing in the manifest. And then the system provides a set of facilities on top of that, such as, people, an IT admin can come in and query the events to find out where the problems are. The events themselves are now described using an XML schema, and we can go do interesting queries or filters on it.
Now, when you're talking about events, what do you mean by events in the operating system?
So today, when applications or operating system components are running, right, they describe, say, either a failure or something interesting happened. I couldn't read the hard drive, or I had a problem, or I wanted to just checkpoint and say I'm here. They describe this in the event log, or they create private logs for themselves. They probably write the logs to a file. And at the end of the day, the administrator who's trying to manage this machine has to come in and make sense of, if there's a problem, where is the problem? Is it in the system? Is it in the application? What might have triggered the problem? So this is a big area of concern for people who are managing Windows desktop, especially. So we are trying to say that in the Longhorn timeframe, there is a lot of work happening to say, we will start with what is the event system today. So people who are using those APIs automatically can buy into some of the benefits. So a bunch of extra information when you call APIs like report event today, there is a bunch of extra metadata kept about that event by the system. And then on top of that, you can define your own custom events. And there is infrastructure to filter them. So the admin can say, I'm only interested in, severity 1 events. Only log severity 1 events, or only log events of a certain type. So we've looked at that whole scenario of looking at application diagnostic information and managing a system and provided value in that pipeline. I think.
Now, I know later on today I'm going to be talking to some people about Monad. What can you say about what Monad is and how that applies to the whole fundamentals aspect?
Monad is about managing. I mean, I'm not an expert on Monad, first of all, I should start. So I think the second talk is probably the right thing to focus on. But Monad is about helping admins do admin tasks and managing that easily, is my understanding. And they're looking at how do you make all of Windows admin tasks scriptable, make them easy for admins to understand and actually run the operations of managing a Windows system. That's my...
Scriptable and reproducible and understandable from that standpoint.
Yes.
Make it easier to manage. I mean, because Windows systems are relatively easy to manage, but they're not the easiest systems to manage out there. They're the systems that have this underlying command line driven sorts of capabilities.
Yeah.
And I think understanding all the different flavors of how you want to interact with the system is also an important thing to think about from a fundamentals.
Well, think about what you mean by easy to manage, though. I mean, if you say something's easy to manage, I think a big fallacy has been that we provide GUI tools to do stuff. In fact, the number of things that people need to do from a management point of view are probably way outweigh the easy ways that we can make it done via a tool. If you have a tool and it's all point and click and drag and drop, that's all very well, but many times you need scheduled tasks to go off and do things. You need to be able to combine things in specific orders because you want to actually go off and do one thing and then conditionally go and do something else. In many ways, Windows isn't as easy to deal with. It's not that the functionality isn't there, but if you're reliant on the system to provide the tools to do it, then that kind of scopes your view a little bit. Providing scriptability is actually, it really gives you the ability to look at the richness of the things that you can do.
But this thing also requires the developer of those applications to think about scriptability and think about how does my application involve this. I mean, if I'm writing Notepad or something like that, I'm not thinking about developing Notepad in such a way that someone else can script into it and have it select text and find
Correct.
text and replace text like that. But if now in a fundamentals model, if I want to do that as a developer, I would need to be thinking about, okay, how do I provide programmatic access into the features and capabilities of my application?
I mean, but there's a negative side of it, which is you think about, well, my own thing, my own application isn't the whole world, but the other side of it is that if I think about it from how it's going to be consumed, and it may just be one link in the chain, I'm actually making things easy for my customers because it may well be completely conditional the way it's going to be activated or used, and so it's actually maybe it takes some of the burden off you. I
would say providing that consistent way of doing everything, all administrative tasks are scriptable, which going back to Glenn's point, right, is important. And then GUI can be built on top to make experiences simpler, because whenever you want to combine things, or you say this task involves these 5 things, it's pretty hard to do in Windows today sometimes. And so having that substrate that says any administrative task is always available, and then building on top of that any UI is I think one of the important.
Typically, if you talk to a customer, they regard ease of management as being, it doesn't matter if there are a lot of tools that they have to write, because they're used to doing that from the old systems like Unix, etc. But easy to manage involves being able to know what state the system is in. So it goes back to the eventing side of things that Sanjay was talking about. It's the ability to execute things based on the information, the operational information that you're getting from the system. All of those kinds of things. That's what makes something easy to manage.
And another interesting thing, and I'm sure a lot of people who are using the Windows systems have seen the error report logs that come up, which let you actually send information back to Microsoft's website, so we can actually figure out what the top problems are and solve them. We've already started a program where ISVs can participate in that.
Oh, that's good.
And that's something we're also going to take forward in Longhorn. So some of the error reporting and feedback loop. We think the feedback loop is really critical, right? Microsoft has really learned a lot from it and leveraged that. That's something the ISV community, I think, would also love to have, and that's something we would like to provide more of going forward.
Because I know that's one of the things I've heard in the conferences I go to and stuff, developers asking, how can I take and get access to some of that information that comes back?
Yeah, I think on the Microsoft.com website, there is already information about this. So if you search for error reporting, I think it's been called at Microsoft.com, if I'm.
Okay, I'll look into that. I'll make sure I stick it in the transcript so people watching the show just go over the transcript and find that link to that information. So we're just about out of time now. In closing, I'd like to kind of find out from each one of you, what would you say to today's developers developing today's applications on today's operating systems? What should they be doing now in their applications so that not only they're writing better applications today, but also being prepared for the fundamentals coming out in Longhorn in the future?
From my perspective, I would say if you're actually looking at managed code already, with the new frameworks we have, with the WIDB framework, we have this work called Click Once coming out, and that's really a glimpse of what's coming in the future. So getting there and looking at it would be a very important thing for people. And just think about this fundamentals life cycle as we talked about early on. And there are a lot of the tools are already available. A lot of the capabilities are already available today. But following those guidelines would really help you get on path for Longhorn. Right?
Hey, Glenn?
I think quality will always be a big focus. So firstly, I would focus on the quality. I would look at books like Writing Secure Code by Michael Howard. Give Michael a plug. I would look at the quality first. Secondly, I would think about the least privilege aspects of things. Develop if possible, but certainly test with least privilege. And thirdly, I would think about how my application is going to be used. So, for example, many utilities require users to enter alternate credentials. Basically, I log on as one user. I prompt the user for credentials to do things that my application wants to do. Think about the system services that are available there, and don't just think about the world as you understand it. So I'm thinking about that from the point of view of enterprises want to move forward. They want to use richer and stronger credentials as they become available or more widely deployed, like smart cards. Use the system and try and be as agnostic about those kinds of things. Also, if you kind of almost a related point about the agnosticism aspect of things, think about your application. If you really are a security application, think about it from the point of view of the target markets that you're going to work with, and try and think that somebody in that market may not want to do the same kind of crypto things that you want to do. So try and make your application as crypto agnostic as it could be going forward. They would be the things I would say, thinking about Longhorn.
Okay, well, thank you.
Thanks.
Thank you.
So hopefully that gives you some insight of what the fundamentals are and what's the sort of things you need to think about in developing your applications to make them more secure, more deployable, more usable by the users in both today's environment as well as Longhorn in the future. After the short break, we'll come back, we'll take a look at what Monad is and how that might help applications in the future. Welcome back. Now, earlier we talked about just the fundamentals from an architectural standpoint, dealing with security, click once, and that sort of stuff. Now I want to take and try to dive into some of the programmer aspects associated with understanding the fundamentals of Longhorn. Specifically, a technology that we call Monad. It's a new technology coming out that we think will greatly improve the capabilities that a programmer can add to their application, as well as providing great access to features on the system itself. Here to talk to me about that, we have Jeffrey Snover and Jim Truher. Thanks for joining us. Now, could you spend a couple seconds letting us know who you are and exactly what you do at Microsoft?
Sure. So I'm the architect for Monad. I invented this technology. I was looking at the .NET frameworks and tools and technologies and saw some great opportunities for automation. And so I invented this technology, and I'm the architect for it.
So you're the father of Monad.
There you go. Well, one of the fathers.
Okay.
We got a great team, including Jim here, to sign up and take it the rest of the way.
I'm a program manager on the team. I was responsible for building up the language, the interactive model, how the language interacts with the users, and I own a number of other feature areas in the product.
Okay. So first question is, what does Monad stand for?
Monad is actually comes from Leibniz. He had a philosophy that said that the whole world was based upon the principle of composition. And so that was just a fantastic mascot for our project, where we're all about composition, composing solutions to automation problems.
I see. And what exactly is Monad?
So Monad is it's a way to automate the system. It has four components. First is it's as interactive and composable as K-shell or Bash. So if you're familiar with those types of shells, we have those capabilities. It's also as programmatic as, say, Perl or Ruby. So when you really need to get great automation, to really get sophisticated, you don't have to switch tools. The same tool can be both interactive and programmatic. Third is we focused in on some production-oriented capabilities of it, like VMS's DCL or the AS400. We're really focused in on trying to solve admin's problems. And then fourth, we go and we take all the management information in your system and make it as easy to find as files in the file system. So for developers, it's a way that they can participate in Microsoft's strong focus in on automation and to line up with our initiatives around dynamic systems. And it's a hosting environment, okay? So you'll see how this is very different than traditional approaches. How in this world we have commands, we call them commandlets, and they're .NET classes. And then MSH is a hosting environment that takes your .NET classes and surfaces them as commands, where the hosting environment does a ton of the traditional work you had to do as a developer before. So you'll see you just get fantastic productivity out of this environment.
You're obviously not a proud father, are you? Now, you mentioned the .NET framework and stuff like that. What are some of the benefits the .NET framework provided you in developing this?
Sure. So the thing about management, management really has been disappointing. Yeah, it really has not achieved its potential, delivered the value it needs to deliver to customers. And why is that, right? Are we bad guys? Are we dummies? And the answer is no. One of the reasons why it hasn't achieved its potential is that we go around rewriting a bunch of technology. Okay, so mainstream programming technology has never given us in the management business really what we needed. Okay, it's often been about private conversations. I produce my objects, I consume my objects. To the degree to which it's a public conversation, it's an early bound, tightly coupled conversation. Here's version 3 of my interface, and I bind to your version 3 of your interface. Well, in management, none of that's been the case. In management, we always had to say, I walk up to some object I have nothing about, and I say, what are your properties, what are your values, what are your methods, and I'm going to get some value over the course of time, and if it ever turns above 80, I'm going to turn something blue, okay, red. And mainstream programming technology has never given us that. And so what we had to do was we had to reinvent all that, or invent all that technology. So basically we were cut off from the mainstream of programming technology, and we couldn't take advantage of that great investment. So as I looked at .NET, what I discovered was that it was now providing the majority of what we needed out of management. So now for the first time ever, we can do management solutions layering on top of mainstream technologies. And in particular, it's the reflection APIs, the ability to walk up to any object and say, object, tell me about your properties, tell me about your methods. And so you'll see what we've done is we've exploited the .NET architecture to dramatically repartition the way automation has been done. I mean, typically there's been the shell, the command line, a set of domain-specific utilities, and a set of domain-independent utilities, awk, grep, sed. And what .NET allows us to do is to repartition who does what, and allows an engine to do the vast majority of the work, and only ask programmers to write the code that they and only they can provide, and we'll do the rest of it for them. So the power's been fantastic.
Now, earlier on, you kind of described Monad and how it related to other technologies and other systems. It's like this, it's like that. Now, some of what the .NET brings you and be able to actually interrogate objects and understand what they're doing, is that something you can't do on some of the other systems in the same direction?
Yeah, that's right. Java has it to some degree, but .NET is the thing that, the great thing about .NET is that you don't have to pick a language, right? So that different people, different programmers with different skill sets will choose the programming language that they like, and this will work with it. It's not the sort of thing that says, well, it's going to work as long as everyone adopts a single language. If you think about it, there's really been 2 generations of composable computing based upon extraordinarily simple concepts, and we're building a third. The first was Unix. It said, hey, if we just put all of our data in ASCII text files, then I can build a set of compositional utilities, awk, grep, sed, to manipulate those. It's worked extraordinarily well. I assert SQL is based upon something equally simple. What it said was, hey, let's just agree upon the form of the data. Let's put things in tables. We'll have identify some of those columns as keys, and then SQL can build things like indexes, queries, joins, do massive domain-independent composition of that data. With .NET, we now agree upon what an object is. Not your language has your object, your language has your object. We agree upon what an object is, and allows us to build a set of domain independent object manipulation. So you'll see as we demo some of this, it has a lot of the characteristics of the shells of Perl, etc., but also has characteristics of SQL. Okay, so what we've done is we've replaced the traditional pipelines of text objects, right? A pipe to B, pipe to C, text. Yeah? What that really meant was your customers had to become text parsing experts to get something done. What we've done is we've replaced that pipeline of text with pipelines of objects.
So rather than the data being the unifying feature, the objects themselves the unifying feature.
Exactly.
Okay. Why don't we take a look at what some of this code looks like?
Great. So Jim, let's show them some of the code here. Robert, so this is now, in this world, our commands are called commandlets, and they're classes. And so here we have a class, getPS1, which is a subclass of commandlet. And you notice we use attributes. You're going to see how we leverage the .NET programming model, and specifically the attributes, it's a way that programmers transfer work from the, to us, okay? So here we declare the class to be a commandlet, and we identify the verb and the noun. Monad is very verb-noun oriented, okay? So this is going to get surfaced as the get PS1 command. And then you override one of a couple methods, okay? Here we're going to do begin processing. You'll see we're very record-oriented, okay? So you'll see later how the objects in a pipeline get transformed into records, and then we call your class's property process record for once for every object in the pipeline. And then we call begin processing at the beginning and end process at the end. And you can override one or all of those methods. Here, we override the first one, begin processing. And what we do is we call write objects. And here we're leveraging the fact that there already exists a process class, and it gets all the processes. Okay?
Now, overall, what specifically is the goal of this commandlet?
So the goal of this commandlet is to get all the processes on the system and then give them to Monad, and then Monad's going to manipulate them. So let's compile it.
Exactly. It's a very, very very simple commandlet.
Is it simple?
Yes. Simply does calls the .NET get processes API and surfaces whatever is returned from that API right directly to the shell.
And then we'll show a more complicated example in a minute. Okay, so we've already compiled it, and we run it, and we get all the processes. Now, what actually happened there was it produced a set of objects, and then they get handed to the hosting environment. The hosting environment looks at those things, determines which set of properties it should surface, and here we've surfaced it as a table. But now we've written 5 lines of code. I should be able to get more value out of it than just that. How about it, Jim? What else can I do?
Well, if I actually want to find out what all the bits and pieces are of those objects, I have another command that uses reflection to acquire that object, crack the object apart, and tell me what properties are part of that. So I can say, get me that and show me its members. That's not terribly useful in the display, so I can change its display, and I can say, show me this as a list. And so each one of those objects that's coming out gives me tells me what type it is, shows me the sort of information that object has.
Right, so here we've shown all the properties that you can now manipulate. So now let's say, hey, I wrote 5 lines of code. I want to get some value out of here. I don't want all the processes. I just want just those where the handle count is, say, greater than 500. And then I want to sort them by handle count. And here we're leveraging the domain independent object-based manipulation utilities to do that.
And before you get encouraged on this, so what I'm seeing on this line there, get PS1, this is the code that you wrote, basically, and all it did was enumerate through the processes and calls the right object to write it out with.
Exactly.
That's correct.
And now you're modifying that on the command line to specify how you want Monad itself to manipulate that object when it's putting out information or processing an information, and your commandlet has no idea what's going on at all.
That's exactly right. The PS1 command, it just says, here shall take these objects, and if I take those objects and put them into the pipe stream, then I can then do more data manipulation. In this particular case, I'm saying, evaluate the property handle count and the objects that you get, and only show me those things that are over, that have a value that's over 500. And with those, so I've winnowed down that list of objects, and then I pass that to the next command, doesn't know what they are. He reflects against the objects as well, says, oh, there's a handle count property. I can sort by that. I know how to sort against that sort of a type, and it will sort it and provide me the output, and there I have it.
Great. So now let's show one where we, the great thing about the objects here is we're reflecting against the objects. And in .NET, we're asking for the properties. And in .NET, the properties are objects as well. And being properties objects, they have properties which have, or objects which have properties. So basically, we're going to get these process objects, and we go to them, and it has a property called main module. Now, the main module describes the file that's running that executable. And the great thing about that is that the file can reflect back to the file version block. And the great thing about the file version block is that sometimes people actually populate it. And when they do, they can fill out things like the file description. So here, take a look at those processes, right? What are they doing? Right, what are they doing on your system?
Sometimes I'd really like to know.
Absolutely.
And so now what we'll do is we'll navigate from that process object to the file name to the file version block and get the description and answer that question for you. Okay?
So in this particular case, all I've done is I've taken the same pipeline that I did before and add to the pipeline, this is the information that I want to see. Show me the process name and show me the file description. Many cases, it's not filled in, but in many cases it is, and you can actually go through all of the processes running on your system, getting that information.
Now, Robert, we're very focused in on the console, but that does not mean we're walking away from what made Microsoft great. Go ahead and show them.
Right, so if, for example, what I wanted to do is, what's a good tool? Excel? Maybe if I wanted to say, show me these processes and put them in an Excel spreadsheet. So I'll do it.
Exactly.
Wow.
And so what's happened here is we've taken those objects, converted them so that Excel knows how to deal with these objects, and I've created, for each one of the properties in that object, I've created a column name. So I've got base priority, exit code, has exited, all of these things, and I just fill into the Excel spreadsheet all the information that was part of those objects.
Now imagine the case where you said, hey, my boss is coming here, wants to know what's consuming all the resources on a machine. You might do something like get all the processes. Get all the processes.
Yeah, let's do that.
Sort them by handle count. Do a tail to get the last few, and then output them as a chart with the process name and then the handle count. And there you go. So
Wow.
in this world, I mean, notice in the old world, you had a bunch of text parsing. Cut off so many lines, go over so many columns, pray that there's not a tab there, take a look at that string. What is that string? 32, 64 bit, so it's a bunch of prayer-based parsing.
Yeah.
And here, you think about what you want, you type it, and you get it. It's really powerful.
Even after I did the convert to CSV and open up Excel and pull it in CSV, I'd still have to select the data and create a chart out of it, where this did it in all one fell swoop.
That's correct.
Exactly correct. And so again, this is part of the leverage. You spent 5 lines of code and you got this. Now here we've shown you a very command-oriented environment. And that's great because a bunch of admins love command lines and they're going to do that. But to get great total cost of ownership, to get great automation, you have to have great scripting. So now we'll show you some of the programmatic aspects. Again, leveraging your 5 lines of code. So here what we'll do is we'll run the command and we'll assign the results to a variable. And now it's in a variable. So now we can access that variable, get the first element. Okay, and that's an object, right? So go ahead and get that and get its process name.
Okay, wait. So the get PS1 command is automatically enumerating through all of the processes, and it would have returned those back to the screen. However, you just taken and had to put it into an array.
Exactly.
Now that array is known by the system, and you can take and access and development of that array just by doing a subset.
That's
yeah, and
correct.
it's not the text, it's the objects. So you can render it however you want to.
So if I wanted to get to the process name, all I need to do is say, show me the process name of that first one.
And then we've got a rich set of control structures. Go ahead and show them the for each. So, a lot of scripting languages went and did kind of wacky control structures. If was terminated with a fee. We rejected all of that and adopted the C# model. Okay, so what you're going to see is that as you're learning this and you're manipulating the .NET objects through the command line and through our script language, what's really happening is you're learning the .NET objects, you're learning the properties and the method names, and a bunch of the C# control structures. So if and when you decide, hey, I don't want to do this in script, I want to do it in systems programming, there's a very nice glide path between this and C#. So here what he's showing you is a C# type control structure for each. Notice we use the brackets and we use the braces. And here is a slight twist to it. So it's for each $P in, and then we have a full. Indeed, you get a lot for it. This is a little program here. And so what it did was, it's not just, it says in P where, get the processes, where the handle count, pipe it through sort. That's all part of the control structure. And then we pipe it to a formatting string, and you'll recognize this as the .NET formatting string. And we go and get P process name and P handle count, and you get it. So very rich programmatic control. Great. So now let's show the next. That was great for 5 lines of code, but now you want to do something more sophisticated. So let's go back to the code. So here we're going to show how you can leverage the .NET attributes to do more, have us do more work for you. So command line, here we showed get PS1. There were no parameters on the command line. Now we're going to have parameters. How does it work? Well, all you have to do is to put in your class a property name and declare it to be a parameter, and then it will be a parameter. See, what's happening is this class is actually driving a common parser for you. You don't have to do any of the parsing, any of the output, any of the data validation. So here you see we've got a public string array of strings called process name, and above it again a .NET attribute saying it's a parameter. Position equals 0 says you can say minus process name and then give it process name, or you can just put the value in position 0, and we'll take it, we'll map it to this array. And next it says pipeline equals pipeline input as is. That allows us to take objects from the pipeline and pipe the results to this property. Then now we override process record. This is going to be called once for every element in a pipeline, and before it gets called, the hosting engine has populated the property process name. So now what you do is you say, if the process name's not null, then get the string for each process name and write it out by name. Otherwise, return them all. Okay, so now we got a dozen lines of code. Jim, let's show us what we can do with that.
All right, so we've got a new commandlet. Without any arguments, remember it just will return all of them, so it looks a lot like the PS1 does, but the more interesting point is if we start adding, so we'll use process name, look for MSH, LSASS, and service host.
Notice you can give multiple values, and we code those multiple values in the string array.
And you get the list of processes that match all of those things, right?
Yeah.
So that's a lot of typing, and I'm an okay typist, but lots of folks would like to type a lot less. So we do a lot of disambiguation. We wind up trying to figure out what thing you really meant and try to do what you meant. If we can't decide, we tell you that we don't know what to do with this. But in this case, I've only got one parameter, and so I can say, okay, I just want to say minus P, and I get, so I don't actually have to type out the entire parameter name. We'll match, do the best match, give you the match that we can give you, and then run the command in the same way.
Because you only had one parameter with a P at the front of it.
That's exactly right.
And if you had 2 with P, then you'd have to give 2 characters to tell us which it was.
So if you were the developer of this commandlet, you probably wouldn't want to have 2 parameters, one called process name, and the other one called process names. You'd want to probably try to change those letters a little bit earlier on.
Exactly correct.
That's right.
Yeah. But it's something we want to highlight here is, sometimes verbosity is your friend, and sometimes verbosity is your enemy. Verbosity is your friend when you're reading a script that you wrote last year or reading somebody else's script. There you want full names, okay, and we fully support that. Verbosity is not your friend when you're a power user and you're doing a bunch of stuff interactively. And there we support you as well through aliases and disambiguation. So we support both worlds. It's not an either-or situation. So in fact, we can even make it shorter by using the positional parameters.
Yeah, remember that one line that said position 0. So now what I'm doing here is I'm not specifying any parameter, but I have specified in the code that says if you get a set of some input in the first position, in the 0th position, just assign it to this parameter and there you go. So I don't even actually have to type anything.
Now you can also pipeline strings to this object. So here, this is an array of strings.
Yeah,
And then
that's what it looks like if you just type it. And so now, if I type this to get PS2, type this to get PS2, it should give me the same output. And indeed it does.
yeah. So now let's focus in on even a more sophisticated example where again you have the MSH do more work for you. Okay, this is the code to stop a process. Okay, again, it's a class. Again, you put the commandlet attribute on top of it. And here we have a public int array of integers called ID. So we're going to kill processes by their process ID. And we've got attributes on top of it. The first says that it's mandatory, that you must give us this value. The next says that it can be pipelined. The third says that it can be in position 0. And then there's another attribute that says prompt. This is a string that you can tell us to use if they haven't given us the parameter. So we said it's mandatory, and if they haven't provided it, what do we do? And there are internationalized versions of this as well. We then, again, override.
Dude is not an international name word there?
Not really.
Okay.
It doesn't pass muster.
So then we're going to process record. Again, this gets called once for every object in the pipeline. And what we do here, we'll walk through it a little slow to get this. So we've got a process called P, and we're going to say for each ID that you've given. We now call something called should process. Okay? Whenever you run a command that's going to have a side effect on the system, you have to call should process. And I'll show you what that provides in a minute. But just whenever you do something that's going to have an effect on the system, you call this. It's a Boolean.
Killing a process.
Like killing a process, formatting the disk, things like that. You can go ahead and call this, and we'll tell you whether to proceed or not. Okay? Then we go ahead and we try and kill it. And again, that can succeed or fail. So we get the process by ID, and then we call the kill method on it. Now, this can fail. It can fail for a couple reasons. The first is it can fail because you don't have permissions. That's what we handle with the first catch block. And what we do is we do a write error with the exception, an error category, in the object that you had a problem with, okay, that had the exception. The other is that it might not exist, right? You specify a command that doesn't exist. So we do the same thing, but now the error category is object not found. Now notice the lack of standard in, standard out, standard error. Okay, we have equivalents, right? But you write the objects. That's sort of the equivalent of write standard output, but it's very different. Here, write error is sort of like standard error, but it's very different. And there is no equivalent of standard in. We control the standard in and call your process records.
So how are these different than standard in and standard error?
They're object-based. That's the key.
So you're not doing to a data stream, you're actually doing to an object, and the object is figuring out what the right thing to do is.
Exactly. And so what happens really, okay, when you pipe A, pipe to B, pipe to C, in our system, what really happens underneath the covers is we in fact set up a data flow engine, okay? And when you do a write output, write objects or write error, the data from that first processing unit then controls the execution of the subsequent processing units. So to the user, it looks very similar, very traditional, very normal. Underneath the covers, it's very powerful. Now the power of this is that then B can say, hey, I need a string, okay, or I need a whatever type of parameter is. When you do a write object, we're not just directly taking your objects and passing it to it. What we're doing is we're taking that data, understanding what the guy next downstream needs, and we're doing whatever data coercion's required to match things up. So we do a ton of work for you. Okay, so let's go ahead and build this and run it.
So it's already built, but since we're going to be doing a bunch of process killing, I'm going to create myself a little function to get me a notepad pretty quickly. So I'll just create a function called n, starts a notepad, and then I'll get a notepad process information.
Because we're going to work on the process
I'm going to
IDs.
try to kill this a lot, and I'm going to want to have that process ID. So now I have this function that starts a notepad and returns me the ID, so I can then take that, and now I'll say stop PS1 and kill it. So ID 172. Away it goes. Well, as we did in the other one, we have, that's an array event. So if I wanted to create a couple of these, so now I've got two notepads running. There we are. And, yep, that's what I have. And now what I can do is I can kill those, stop PS1, I'll kill 2668 and 4044. And so I've killed them both. They're both gone, and it's pretty straightforward.
Now show how the mandatory works.
So if I give myself a new notepad here, and I'll say, okay, now I've got to know I'll stop my process. Now I'm not giving it a thing, and we've not giving it an ID number, and it said, this is mandatory. So it says, hey, what's the ID, dude? So I can give it the ID, and away it goes. Goes it up, kills it right off.
Exactly. Now, remember in the code where we said, hey, before you go have a side effect, call this should process. Let me show you what that's about. So create a couple processes here, a couple notepads.
So now I've got a couple of them.
Okay. Now we'll do a get all the processes called notepad. Let's make sure that works. Yeah, and now we'll pipeline that in. Remember, we supported pipelining. So now we're going to take these objects and directly pipeline them to stop PS1, and we'll say, geez, maybe this is a good idea, and maybe it's not. Yeah, often I've talked to admins, and they said, every now and again, I'm about to hit the carriage return, and I realize I might affect my company's stock price with this carriage return, right? I might end my career with this carriage return. Well, that's a lousy world. So if you're not sure whether this is a good thing to do or not, what's really going to happen, you can always type minus what if.
What if I do this? What's going to happen?
Okay, and what happens is we then tell you what would have happened, and we put a comment character at the beginning indicating that it didn't happen, that we didn't actually do it, okay? And this is especially powerful. With here, we told you exactly what was going to happen, but you might have had a complex script there or some complex target evaluation to do this, and this really helps you with that. Now imagine...
So you might have said something like, stop all processes whose ID is greater than 5 and less than 28, and you forgot that there was an ID in there that was,
LSAFS.
Exactly.
Yeah.
So, our get process is a little bit more sophisticated. So why don't we show you an example of that with the targeting rules. So in fact, what you can do is GPS, get process, that's an alias, bracket, A-C star, comma, T through Z star, bracket T through Z star, space, minus exclude, star, bracket T dash D, pipe to stop process. Okay, now don't hit carriage return. So let me explain what we just did there. Okay, so in fact, we have extraordinarily rich capabilities. Okay, so here our production get process does globbing against the process names, right? Traditional shells, they do globbing against file names. Here, because we have the objects and we have the properties, we can do globbing against almost any object. And so what we did was we produced a globber for process objects. It says, hey, get me all those whose names begin with A to C, or the ones that begin with T through Z. And so there's positive expressions, and you can have a negative expression. I want you to exclude the ones whose name end with a T through a D. Okay, now this might be good and it might be bad. And this is where you'd want to say minus what if.
Shall we?
And it's probably a good thing we didn't do that. Okay, so now go back to the code we did in the sample, and we did a what if. You just go back to the what if. And you say, well, that was, go ahead and hit carriage return. this is almost right, but it's not quite right. So what you can do is you can say minus confirm.
What this is going to do is it's going to make sure every time it could act, it's going to ask you, should I act? It's going to give you some options as well. So it gives us a couple of options. It tells us what it's going to do. I'm about to kill the process 2584. Yes? You want me to say yes to everything? No? Don't do anything? And then we have suspend and help. Suspend actually allows me to get into a sub shell so I can then investigate the entire environment as I'm working, so I can kind of get a better clue on what's happening in the environment. I can do all sorts of investigation.
Yeah, so basically remember that call where it said should process? What's happening is now we take that and you're on hold. We're working with the user, find out what it does. If he types yes, we return a Boolean true. If he types no, we return a Boolean false. So go ahead and say no to this one and yes to this one. And so we've deleted one of them, but not the other. Additionally, we use the same mechanism to support verbose. So you say verbose and we tell you exactly what went on. Okay? I mentioned to you
Got
that
one left, so away it goes.
great, and let's produce a couple more. Oh, actually, you know what? Now we'll show you some of the features. This is the sort of thing we put in the category of production orientation, right? Focus in on the problems of admins. One of the biggest problems of admins is that stuff goes wrong a lot. Okay, so imagine you want to perform an operation on 1,000 machines, right? How many times does that work, right? About
Once.
0. Yeah, once, okay. Mostly it never works, right? Works on 950 and fails on 50, right? Same thing whether it's AD entries or files or registry entries. When you're doing it on a lot, it rarely works on all of them. And the question is, well, then what do you do when it fails, right? Often the answer is you start scouting for an intern. Hey, Bucko, come here. I got some work for you to do. No, this is what interns do. Slog through this log and fix it, right? Well, again, that's kind of a low-class answer, okay? And so what we've done is we treat errors as a first-class citizen, okay? When you pipeline something in or you're going to operate on multiple objects, the ones that succeed, they go one path. The ones that fail, they go down another path. And we collect all them as a collection of objects that you can then perform a remedial action on and control.
And this is where catching those errors comes into play, and the right error is being used.
Exactly.
That's right.
Jim?
So let's take a look here. We'll stop PS and we'll give it a couple of bad IDs. See what happens here. It says, well, that's certainly reasonable. I can't do anything with this. But if I'm doing this sort of thing and I want to say, the first time that you hit an error, I want you to stop doing anything, right? So what we've done here is I've given it a couple of error IDs, process IDs that aren't on the system. And so when I run through this, it will tell me that none of these processes are running. And so I can say, if when you hit an error, I want you to stop what you're doing and let me know. And so I can set a flag that says, set my error policy that says, notify me and stop. So what this does is it says, well, the first time that there's an error, that is to say, something that we could recover from but keep going, but I want you to turn it into a fatal exception and throw everything to be stopped. And so what happens is it gives me my first error message that says I couldn't find this particular ID, and then it says, I'm sorry, I'm stopped. You can't go on. There's a fatal error has occurred. If, however, I wanted to say, well, let me decide whether we should go on or not, then what we can do is we can say, ask me, inquire. And so now what's going to happen is every time it finds something that isn't successful, it's going to say, do you want to continue? Do you really want to keep going? And in this particular case, yes, go ahead. It's going to ask me again. There was another error.
Show them suspend. So often what you're doing this because something might go wrong, but you're not sure what. And so what you can do is you can see the error, hit suspend, you get a prompt, you can look around, perform any operation you want, and then when you type exit, you're back to where you were, asking now what do you want us to do? And here we'll say no.
So if it came up across an error like, file is currently opened and locked for write or something like that, you can kind of look in and find out what was going on. And say, oh, that was the problem. Close down that process, have it open, and then continue with the process going on.
That's exactly right.
Yeah. Yeah. Now notice, remember when we wrote that code? you didn't write a parameter called error policy, so how's this working? Well, what happens is you subclass off command. The command base, in fact, provides a ton of common command parameters, okay? So things like the error policy, that minus verbose, minus confirm, etc. So again, it's the leverage you get out of our hosting environment. A bunch of base parameters are provided by us, they're implemented by us, and you're the beneficiary of that as a programmer. Yeah. So all in all, that's the key point. Now, I mentioned to you at the beginning the 4 things that we did, and I've shown you the 3. An interactive and composable shell like K shell or Bash, a programmatic environment like Ruby or Perl, and a production-oriented system like VMSSD, CL, or AS400. But the last thing I mentioned to you was the fact that we can make getting at management information as easy as it is getting at files in a file system. And here we have a programming model for that, but that's more complicated than we can go into today. But we'll show you the results of that. Jim, show them the drives on your system. You'll notice a bunch of the traditional drives, your C drive, your E drive. But notice that now instead of a drive letter, you have drive names. And you've got some unusual things there. You've got an AD drive. You have an HKLM drive. So just as you can do a CD somewhere in a dir, do a dir. Okay? Now you can do a CD to AD and do a dir. And now you're seeing directory entries. Now do a push D into HKLM/software and watch this. So hit tab.
So an HKLM is HK local machine, I'm assuming.
Exactly.
Yep. And this is going into the software key within that.
Exactly. And you can say -M tab. So you do have tab completion in the registry. M tab.
Don't want that one.
And we'll go there and do a dir. Yeah. And you can get the properties of these registry keys. Yeah. And my favorite, okay, do a dir of everything beginning with A. Okay, yeah, good stuff. You can do a dir of all the subchildren that begin with A. And you can control the depth. And you can do recursive directories in the registry and Active Directory, really powerful stuff.
Because then usually what I do is, if I'm running some program, I know it's setting something in registry, like, when I'm installing another, Pocket PC and I want to go in and touch things and find out exactly where it stuck that in, I just start at the top and do a search from regedit, and this would be a lot easier than doing a search from regedit to find out where that was actually happening.
Exactly
right.
correct. There you go.
So this looks like a pretty powerful tool. To me, I'm seeing it targeted towards the IT individuals.
Yeah,
specifically, or
well, IT guys are going to love it. IT pros, folks who do scripting, but also power users, tinkerers, developers. All of us developers. Developers go goo-goo over this stuff. It gives them the control and visibility in the system that they haven't had in a long time.
And so let's say I'm a developer and I'm writing a program, like Notepad, like even a game or something like that. What do I need to do to my application in order to make it discoverable and interactable by Monad?
Sure. So I should have talked about the life cycle of these things. So first and foremost, expose your objects as .NET objects.
So write managed code.
Write managed code.
Seems like that's a recurring theme here when I'm talking to people. What to do. Write managed code is always the first thing out of people's mouths.
Absolutely. It's a wonderful environment. If you haven't done it, start. Write as much managed code as you can. It's wonderful stuff. Next is then to think about the activities of the user and then surface your managed code with that in mind, right? Pick the right level of abstractions, take a look at the guidelines and the samples that we have for how to produce a great environment for the admin. You then produce these classes. You'll compile those classes. You'll run a utility against those DLLs, okay, the DLL. It then creates a file called a commandlet file. So it'll be like get process.commandlet. And that contains an ASCII text file that contains the binding information. So when you type get process, the shell looks at that token, finds the commandlet file, opens it up. It then tells us where your DLL and your class is. We load that, right? We manage its lifecycle. We instantiate your class. We configure your class. We set all the parameters, and we call its methods. And when you're done, we terminate the object as well. It's as simple as that.
And one thing that kind of passes their mind is when I'm seeing this is, we're getting into the piping of applications and stuff like that. Daisy chaining one to the next, and having each one process the previous one's outputs. It almost seems like there might be a market coming up for small little teeny applications that aren't really meant to be Excel, but they're meaning to be something small that by itself maybe is not functional, but when tied inside of a chain of other things, actually provides the IT developer with really cool stuff.
Yeah,
Exactly.
It's the glue. The ability to glue these objects together is so powerful that the applications for it really are, we're talking about making sure that we have a first-class management system, but certainly if it's powerful, if it's usable, things will be built for it.
Mm-hmm.
Yeah, no, in fact, it's also going to be a marketplace for these utilities, all right? We're working with a group inside who've just come up with a compare object utility. And so what that allows you to do is to get all the processes in your system, basically any object, and you can serialize it into XML or into a SQL database, okay? And then, with using their utility, you can get the current set of objects and compare them against the serialized snapshots you had. You identify which properties establish identity, and then which properties you want to compare against. So imagine you're doing processes. You don't really care that the process time has changed. That's always going to change, or the working set. But you might care about identity. Are processes, have they recycled? Are there more processes or less processes? The ones that are there, have the versions of the DLLs that run that process, have they changed? And you can do that.
Even to a point we had one visit where we were talking to a group, and they had processes where the handle counts were continually getting larger and larger and larger, and they didn't really realize that. Well, there's no real automated way to find out about that. Writing a script, it would be easy enough to wait every 30 seconds, find out what the handle count is. Oh, it keeps getting bigger and bigger and bigger, and you can really find out immediately and very easily when things are going south on your system.
Normally you just kind of write those down on a piece of paper and kind of read up and look at it again. Oh, okay.
Yeah,
okay,
exactly
okay.
right.
That's how you know real IT pros, all the Post-it notes that
Yeah.
are on their monitor.
Yeah.
So being able to automate that sort of activity is just extremely powerful.
So has anybody written a game yet?
As it turns
Do you
out,
have Sammy the Snake Runner?
we do have a game on this. Yes, indeed.
Show him Sammy.
Play. The snake.
So this is a game written in Monad.
This is a game written in Monad. That's correct.
I was
Pretty
thinking,
exciting.
games, I think, are one of the most important things because they're what the developer really wants to stress out the operating system the most and find out, what can it do, what can't it do. And, the next guy says, well, gee, there wasn't any sound there. How do we take and get Monad to play sound? Gee, there wasn't any of this there. How do we get to do that? You're always going to get something better.
That's
Actually,
right.
do you have the barking dog? We have a command. We always joke about, well, we're console guys, right? We're not those barking dog guys. Well, in fact, what you have is a command line that has a barking dog that comes up and talks to you.
That's correct. And I wrote.
Just as long as it's not clippy.
Yeah.
No, it's not Clippy. It's the dog. I wrote a commandlet actually to play WMA files.
Well,
So I can go to a directory that has a list of WMA files and just play the list.
play the sound.
And that's a
software.
great thing about it is once you have the commands and the environment where it's easy to manipulate them, basically you can build your own scenarios. You don't have to wait for us to deliver the scenarios to you.
Now, I see an awful lot of cool things here. And, as a developer, I can say, I want to play around with this. Is this something that I, as a developer, could actually start working with right now?
Today, you bet.
Absolutely.
This information, all this stuff is available to you via betaplace.com. And you log into there. You have to have a Passport account. You log in as MSH PDC, lowercase MSH, capital PDC, case does matter. And then in 24 to 48 hours, you'll get the information necessary to download the SDK. And so it's the SDK, it's the executables, we got some great docs, some sample scripts, some sample commandlets, and a very active community on BetaPlace. In fact, I think
Very active.
this is the most successful BetaPlace program they've run, up to and including the fact that we might have crashed it once or twice when we released the
4 or 5
latest
times.
version.
Yeah, we have
It's
more than
very
8,000 people
Wow.
that are participating
Wow.
in the
So,
beta.
well, if you got probably everyone that's watching the show already has it then, it sounds like. But for those that don't have it, what I'll do, I'll work with you to get all that information and include it in the transcript. So if they go to the bottom of the transcript while they're watching the show, They'll find all the information about how to actually get this, what information they need to type in and that sort of stuff, so they won't have any trouble with that.
Excellent. And we're very open to feedback. What are we doing right? What are we doing wrong? If you take a look at the beta plays, we're very responsive to the feedback we get, and really looking forward to figuring out how to make, how to make version 1 the product we want in version 3. Yeah? So we want a very aggressive, very active community telling us the things that we're doing wrong, so we can fix them and ship them right in version 1.
Absolutely.
Now, do either of you guys running a blog currently?
Nope.
No. Have you ever thought about running a blog? Sounds like a great thing for a blog. You can be blogging about what you're doing with Monad and get comments from people at the same time.
Oh, we have a commandlet for a blog. We just haven't used them yet.
You're working too hard to get the functionality done.
That's right.
And let someone else do the blogging stuff. Well, if you think about starting a blog before the show airs, I'll put information about that in the transcript as well.
Okay, great.
We do know that there have been a number of blogs that have mentioned Monad for people that went to the PDC, and there's been 3, 4, 5 different blog entries about Monad, but none of the team has yet.
It sounds like it's the perfect topic for a blog, though.
Indeed. I should say we've been talking about it as Monad. That's our code name. The official name is MSH.
I like Monad better,
Okay. For you, we'll keep it.
Are there any final statements you want to take and give our audience about what they need to know about Monad, what they need to know about the fundamentals and thinking about making their applications just work better on Longhorn and Windows XP?
Yeah, I mean, really the key is to follow the .NET guidelines. Boy, if you follow the .NET guidelines, the world's your oyster. Things are going to flow great. This all builds upon it, and if you do .NET, you write a few extra lines of code to surface it as commands, and then we're able to give you a ton of leverage that you can deliver to your customers at a very low cost. Your customers will love you for it.
And it'll provide, I think, a much better environment for dealing with applications in the entire operating system ecosystem. And I think it really sounds important to me.
Great.
Absolutely.
Well, thanks for joining us. I hope you had fun showing it to me. I know I had fun watching it. I hadn't seen these demos for a while, and I'm going to go out and start writing some typing. I bet I could probably get some code from you to install in my system, right?
Absolutely.
Okay, thanks. Well, hopefully that gives you an idea of what Monad is. Now, in the first half of the show, we talked about the overall architecture, what the fundamentals are. In the second half here, we've talked about a specific part of Longhorn called Monad that's going to assist in part of the fundamentals of writing applications. Fortunately, it's something you can start working on the current operating system today on Windows XP. So hopefully you get a chance to download that and try it out. So stay tuned for the rest of the show, and I'll see you next time.
With me today is Jeff Sandquist. He is an evangelist with the platform evangelism team at Microsoft. Jeff, welcome.
Hi.
So Jeff, one of your biggest projects I know is Channel 9. So why don't you start telling our viewers about Channel 9 and how you got involved in that?
Channel 9's really a fun project that, I'm one of 5 guys behind it. I have to be, clear that there's 5 people that play an equal part in that project. And Channel 9's a website that combines web forums, web logging, and videos, and wikis to, show a different side of Microsoft and get a conversation going between us and our customers. How I got involved in it, we'd just gotten done with the PDC, and Len Pryor, who I work for, called me at home one day, and he said, Jeff, I've just written a doctrine. It's called the Channel 9 Doctrine. And he told this story about when he had this fear of flying, and that by listening on United Airlines to the in-flight audio program, you can listen in the cockpit. And he said, what if we could do something like that with our customers? And we talked a little bit about it. He was taking a little bit of cold medicine at the time, and he wanted to make sure that it wasn't something a little bit crazy. And next thing you know, a short period of time after that, we actually got approval to do the project, and Channel 9 was born.
And how long has the site been up now?
We went live just a little over 30 days ago.
Okay. And what has the response been so far?
I think it's been really good, both internally and externally. When we went live, a lot of people were like, are you really going to do this? Or, I remember actually when we did one of our internal tests of the site just before we went live was April Fool's Day. And I actually got a few emails from people when we said, this is this internal site, here's what we're going to do. And I actually got about 3 emails from people that said, is this an April Fool's joke? You're not actually going to do this externally, are you?
Funny.
And I was like, yes, we are. And so it's been a fun ride. It was, we didn't expect to get, I don't think we expected to get the traffic that we did when it happened. And it's been fun. Not enough sleep from our team, because literally it went live and it was like, wow. And we wanted to do a quiet launch of the site. You can't really do quiet launches, I guess, anymore.
Not in the blog world now.
Not in the weblog world. So we shipped the site, and it was actually almost anticlimactic when we shipped the site. Bryn, our developer, I said, well, we're ready to go. So he said, okay, I'm going to get the database up. So he got the database up. And I said, well, let's bring the web files live. So we propped the ASPX files. And it was like, we're live. He's like, you're kidding? We're live? So next thing you know, the weirdest thing happened. We had a little bit of a viral campaign when we started with it, with people putting little Channel 9 icons on their websites pointing to it. The traffic started to go. And it was like crazy. All of a sudden, we had people registering it, and we hadn't even told anybody about it. Even Robert Scoble on our team, he hadn't, said that it's live on his weblog.
How did they find out about it?
People were clicking. We had put a little test pattern page up that looked like the test bars on a TV station in the middle of the night.
Yeah, I saw that.
And we had people that were linking to it and just saying, hey, coming soon. And we'd shown a few people, externally to get some feedback on what we're doing. And we asked them not to really give specifics, but that we were coming up with something. And we'd say, hey, something's coming soon. And all of a sudden they clicked and go, hey, something's live. And then I asked one customer, I said, what did you do when you found out? He said, I instant messaged everybody on my list and said, come to the site. And one person tells somebody. People started weblogging about it. It was crazy.
Yeah, free PR. That's great.
It was pretty crazy. And we weren't sure. I mean, that night when we went home that Monday night, traffic was starting to grow. And I don't think I slept really at all that night. I went home, we're checking the site. The next morning, it was just unbelievable. So, it's just begun. We're listening to what people, are looking for on the site and adjusting, and I think it's just going to get better.
So you have Microsoft people writing blogs. Do you have external people writing them as well?
The whole site is really, I always say that there's different ways that different people want to communicate or even participate in Channel 9. When I look at Channel 9, there's the videos. The reason why we went down the video format was that not everybody has the time as a Microsoft employee necessarily to write a weblog. But if we can go in and have an interview with somebody like Bill Hill or Anders or, somebody who's, a builder on a team, we can go down and just have a conversation with them for about an hour. And we can cut out small little bits, like little 2-minute, tiny little bits of pieces and put them up on video. That's a great way for him to get out to customers and get that exposure. And Bill Hill, when he wrote Homo Sapiens 1.0, which is one of our more popular videos on our site, when he did that, that would have been a perfect weblog entry. But he doesn't write a weblog, so we're able to get that out there. That's one way that we have conversations happening on our site. The next way is through our forums. Every single piece of content on Channel 9 has discussions that follow up on it.
Okay.
Now, what's really neat is like we had a WinFS video that we shipped the other day. And Sam Drucker, the lead developer for that, we posted this video. People asked questions based on the video. Sam was right in there answering them, and that just, is incredible.
That's great.
Other ways that we've got for people to communicate is we have polls and we have a wiki. And I'm not the expert on wikis, but a wiki was something invented by Ward Cunningham, who now works at Microsoft. And it's really web pages that anybody can edit who comes to the site. It's a Hawaiian word for quick. Wiki is Hawaiian for quick. And we have those on there. The last way is we don't actually host weblogs on our site. But the last way that people participate in Channel 9 is they write on their own weblogs and they point to content.
Okay. Are you tied into the ASP.NET blogs at all?
A lot of people write about Channel 9. So what happens is somebody who's got a weblog on the blogs.msdn.com or weblogs.asp.net on those sites, they may see something on Channel 9 that they like. They may see something that they don't like. They'll weblog about it. And we're always watching for those things there, and we're trying to bubble them up on our site and get some visibility. A lot of people called it kind of a group weblog. We do have a thing on there that we call the echo chamber. And that's kind of where our team puts and brings prominence to stuff. But the content on the homepage of Channel 9, if you look at it, what we do is we've got videos on the front page, but we also look inside our forums on the site. And if we see a thread started by a customer that's very interesting, or maybe it's getting a little bit of controversy, we bubble that up to the front. So the front page of our site isn't just our videos, it's also all these other different discussions that are going on.
It's a good idea.
It's fun.
Is your focus on trying to show the inside workings of those working on Longhorn, or all technologies at Microsoft?
There's a whole wave of things that are happening. When we first started the project, we were just going to do things around Longhorn, and we got a lot of feedback that said, don't just do Longhorn. The feedback that we got was there's a whole wave of things that are happening, whether it be Windows XP Service Pack 2 or just our current products today. And there's Longhorn, there's Yukon, there's Whidbey. And think about that, paint a stroke across that, and also the people behind it. So it's like a little bit about, how the sausage is made.
Right.
And those are the things that we do. And we're continuously every day, our team is just trying to think about, what can we do, what are people looking for? We're looking on the site for questions that are people getting answered for. We have a tablet PC set of videos coming up, and the questions that are asked all in those interviews are what customers post on Channel 9. The WinFS ones, Sam Drucker goes through the questions that people posted on our site, and he said he's literally in the video going, okay, somebody's asking about that. Okay, yeah, good question, and answering those.
Nice.
And that's what we're doing. It's an experiment. We really are 5 guys from Redmond. When we went and did the site, we did a couple versions of the site. When you're coming up with a product or something like that, you do some prototypes, and they sucked. They weren't that interesting. But then we stepped back, and as a team, we said, what if we were building an enthusiast site? What if we were building a site that, about if somebody who's into motorcycles or into cars or into pocket PCs, what would you build? And we were like, we'd have forums. And somebody said, well, we'd have pictures and we'd have videos. And that's what we tried to build, is if we were building an enthusiast site about things about Microsoft technologies and products and the people, what would it be? And that's what, how we went about Channel 9.
Using all kinds of mediums.
Yeah, it was crazy. And some of it came along, we had the wiki. And literally, the wiki idea came up like 5 days before launching the site. Bryn on our team, we had this page that we called The Goods. And what The Goods was going to be was links to MSDN, links to community sites, and it was going to be a static HTML page that had things on it. And I looked at it, and Bryn and I were walking to get a coffee. I said, the wiki page blows. It's not very interesting at all. And he says, I know. And he said, we have this Channel 9 doctrine that we talk about that's our principles of doing our site, and everything's supposed to be a conversation. We don't just put something on our site unless people can talk about it. He said, yeah, it breaks the doctrine, doesn't it? And I said, yeah. I said, what if we made a wiki? And he was like, that'd be cool. And so he ran back to his office, and I gave him FlexWiki sources that David Ornstein at Microsoft and the community have written. Brent took it, instant message later. Well, that was quick. He says, we now have a wiki. And so what are we going to do about it? And we didn't really know what we were going to put in it. We had a lot of feedback from different people. Some people say, are you nuts? This is a Microsoft page that's going to have, anybody can edit. And we're like, exactly.
Do you have some sort of editorial control? People put,
knock on
irresponsible things up there?
We actually, have this philosophy. I have this philosophy about community sites, and a community is like a bar. And what I mean by that is we're just the barkeep or the staff. For the most part, the community does its thing. If you go into a bar, nobody tells you what conversation to have. If you get out of hand, people do that. So our job with running Channel 9 is to make sure that it's a real comfortable place for people to be. At the end of the day, somebody's got to clean up the peanuts on the floor so you don't have a health code or a fire violation. So we're kind of in there to maybe move threads around to the different forums that make sense. But for the most part, we've had, knock on wood, no major problems. Everybody's been, pretty responsible and a lot of fun. So, we have a flow of content that we put on. When we go in and do our videos, it's a pretty simple process. We see somebody on a distribution list inside, the discussion list inside the company that are really, interesting. We send them a mail and say, hey, can we get together and talk? When we go over, we think a little bit about questions we might ask, but we just let them talk. And we look for them light bulb moments when their eyes light up and they get really, really excited and passionate about something.
So you get to stay pretty cutting edge.
Yeah, and we try and move quickly. We really, really, our dream was that, we're not there yet, but is that if something could happen where, maybe people are asking questions on our site about, a certain product or technology, and they're stumped. Either get the person in there to reply and answer the question, or if a video makes it, can we get a video up that afternoon? That would be the dream. We're not there yet, but maybe we'll get there.
You will be.
Yeah.
So what other things did you work on at Microsoft before Channel 9?
I came to Microsoft, I started Microsoft in PSS. I was a support engineer for Active Server Pages 1.0 and Visual InterDev 1.0, and stayed through doing that until Visual Studio 6.0. And after that, I went to work in MSDN. And I did a lot of different unique projects in MSDN with the online site, worked with you. And that was a lot of fun. And I also did a lot of stuff with visualstudio.net. I was a PM for a number of different features that integrated with MSDN and the actual product.
Okay.
When that was done, I was ready for a change, and I went over to work in the platform evangelism group. And I've been there now for a few years.
Has it been that long?
It actually has been. It's been about 2 or 3 years or something like that. It's gone by very quickly. It's my most favorite place to be in the company. I get to work with customers. I get to do projects like Channel 9.
And of course, you get to work with Robert.
And I get to work with Robert. And it's a really fun group. It's kind of like Hotel California to me. It's like once you come,
is that such a good thing?
It is a good thing because it's sort of like once you come, I don't really want to leave because it's just such a fun group to be in. I've been part of a lot of neat things. When I moved over to the group, Visual Studio was still in alpha, and it was we went off and did a project where we took Microsoft's own internal Siebel implementation, where we use Siebel, which is a CRM system, and we wrapped it with web services. And at the time, I was like, wow, this is really not a big deal. We did this project, but the impact it had for people seeing web services used in a business was just huge. I look back to that, and that's some of my proudest moments of Microsoft. When we were doing the project, I know sometimes Garland Brown, the fellow I worked with on it, there was a time there where we didn't even leave the building. There was about a 3 or 4 day stretch where we were working on some important demos to show that we could actually do this. We never even left the building. I remember my general manager one morning, he had a very important demo the next morning. And he said, and he wanted me to adjust it because the demo that we're doing, because it didn't meet the mark. And he was like, can you do it? And I was like, yes, we can. We got done about 4 in the morning. I've got a couch in my office, and I fell back to sleep. And the next morning he was like knocking on my door, and I heard him. I kind of woke up and I was like, oh, it's morning, and I was pretty tired. I remember him saying, well, it's not like Jeff not to show up. And I was like, open up my door, and I walk out, and there's Vic, and I got the demo. He's like, let me get you a coffee. But it's been hard work, but it's been so rewarding.
Sure.
It's been fun.
So what are some things you like to do outside of work to unwind?
I'm a geek. I think that's a good thing. I'm really into having a lot of different electronics and technology in my home, to my wife's dismay sometimes. But home networking, media center, PC, and doing all sorts of stuff with our Windows Media Center, and writing applications for Media Center is my thing. I've got a neat little setup with a flat screen TV in my house, and my goal is to tie in lots of different devices for home automation and using Media Center as the user experience for that. Do that. We are an early adopter family, from making sure that I'm on this current project right now where I'm looking at having SharePoint set up in my house so that for document management, I think every house should have an intranet. But so that's part of what I do. I've got a 4-year-old little girl who thinks she's an athlete, and she's into soccer, t-ball, and hockey now, which is great because I'm Canadian. So I'm chasing around her in the backyard, and she actually, the other night, I had a little bit extra work to do, and she's like, Daddy, come outside. She says, you can bring your laptop. And
Oh, no. She's well trained.
She's well trained. So so I do that. I love playing Xbox, and I've also got my 4-year-old into Xbox too. So I play a lot of games, and I love to cook. That's about me.
That's great. Well, Jeff, thanks for joining me today.
Thank you.
Well, that brings it to the end of another episode of the .NET Show.
And stay tuned for the next show for an overview of Visual Studio 2005.
Also known as Would-Be.
Right.
And until then, we'll see you on the web.